Continue and try that. Those who have not yet finished, but those who are getting 8, that is really very. Oh, Jimia is stuck. Okay, 8 is very okay. Those who are stuck, make sure that you write to the same base. Make sure that you write to the same base. That is why I think you might be stuck. So this one being log 2 to x, and make sure that you write this to log 2x, log 4, then plus log 2x, and then log of 216 equals to 21 out of 4. Yes, please, Joe, ask.
Master, Master, first part on number 1, the second part where they change the base.
Where they changed the base. Okay, Ojo, let me.
Where the base is changing, like, yes?
Yes, like?
Where, like, I saw log 81 base y out of log y base y squared. I did not understand it well, Master. To change the base.
Okay. Okay, now to change the base, the number you have must be able to give you a hint. Taking an example of this number 1 here, if at all you look at the bases you have, you notice that this is base 2, this is base 4, and this is base 16. All these numbers can be taken to be to one base. Now, but since you have already log 2 to x, it means that it is very possible for you to write the rest of the numbers to the same base. Take an example. In case I have log of 10, let me log of 10, 100. This number, I can write it to the base I want. Take an example. In case I want to express this log of 10, 100 in base 5, it means that I'll have log 5, 100. You look at the number you have here, then over or divide by log of 5, then what has been your base now becomes the number. So the rule that you have to understand is that when I have A and this is B, I have my base as A and the number as B. In case I want to write it to a log of my choice, in case I want to write it to any base of my choice, then this number I have here is the one that must be at the top, and then the number I have here is the one that must be at the bottom. So meaning I can have log MB divided by log of MA. Hope you have understood.
Yes, sir.
Okay. Yes, Mukisa Emerson.
Master, on that number 2, is it 6 log 20 y log 27 or 21? Number
27.
2.
This
Okay.
is 27. That is 27.
I can't even.
Okay. Is the number coming out? Okay, good, good. Faith Flavia, that is good. MP, that is good. Number 2 is still a challenge. I've only seen Faith Flavia sending in. Okay, Lawrence is confirming that it is coming out. So are we getting root 3 and 9? Flavia, can you unmute and you share with us? Yes, Mark, that is good. Flavia, is it possible for you to unmute? Seems Flavia. Anyone who is ready and wants to take us through how you are doing number 2, feel free to unmute and share with us. Anyone? I want someone to lead us on how you are doing number 2. Okay, some people are still lost on number 2. Anyone? I want someone to lead us. Okay.
Just a moment.
Who's leading us? Who's leading us? Someone to come up. No one, no one. Just raise up the hand and you tell us. Okay, Timo, that is good. Oh, Flavia says we cannot hear. Okay, yes, Technospark. Technospark, the next.
Master, we are lost. Master, we are lost.
Oh, you are lost. Okay, okay. Okay, so when you look at number 2 is a quadratic, is a simultaneous equation, meaning that you are going to express those different equations in a simultaneous way. But once you have logarithms, it's not easy for you to solve unless you convert them into variables. So your task is to convert these logarithms into variables. A variable is any number that can be on. So meaning that when I look at log 3 here, I can have this one written in form of log 3. I can have this written in log of 3, and I can have this written in log of 3. Yes, Jimia. Jimia? Okay. Okay. So I'm going to start. I will say 6 log of x plus. I'm going to convert this into log of base of 3. So I can write 6, then times I'll have log of 3 of y over log of 3, 27. I'm writing the same base. This one should give me 7. I go to the second one, I do the same. I write the common log. So I have log of 3 of x over log of 3, 9 plus 4 log 3y is equal to 9. Is everyone fine with that step? Hope that step is fine. Okay, good. So the next step is I'm going to reduce between 7 and 9. What do I know? Very well that when I have log of 327, this is log of 3. Then I ask myself, what is 7 in form of a base and power? That is the same as 3 to power 3. Meaning that when I drop the power, I'll have 3 log of 3, 3. But what is log of 3? So 1. I end up with 3 times 1, which is the same as 3. So where I have log of 327, I'll write when I click back here, I have log of 9. Let me ask, I never wanted to mute everyone. So I have log of 3, 9, which is the same as log 3, 3. But what is 9? Is 3 squared. So when I drop the power, I'll have 2 log of 3, 3, and I end up with my answer as 2. So where I have log 3, 9, I'm going to put a 2. Where I have log of 327, I put a 3. So my first equation is going to become now 6 log of 3x plus 6 log of 3y divided by log 327, which is 3, is equal to 7. Then the second one, we shall have 4 log of 3x out of, but we have gotten log of 3, 9 is the same as 2. Then plus 4 log of 3y is equal to 9. What are you noticing? That now when I come here, I can have these numbers reduced by 2, 1, by 2 can go with the 2, by 3, 1, by 3 goes here in 2 times. Now I'll have my equations become 6 log of 3x plus 2 log of 3y is equal to 7. And then the second we shall have 2 log of 3x plus 4 log of 3y is equal to 9. So once you reach this step, your next thing to do is to write, because you can notice that now log 3x is common here and is common here. Log 3, 9 is common here and is common here. So I'm going to say let log 3x equals to a, and let my log 3y is equal to b. So where there is log 3x, I'm going to put a. Where there is log 3y, I put my b. So I'll have 6a plus 2b is equal to 7. Then I have 2a plus 4b is equal to 9. And when you look at this one, this is a good simultaneous equation that everyone can solve. Can you solve and you give me the answer? When you solve this one, can we solve quickly and then you give me the answer? So, and then you give us the answer. What are you getting? Solve, and then give us the answer. You can use the chat to type in the answers. You can use the chat to type in what you are getting for your value of A and what you are getting for your value of B. Use the chat quickly. Okay. Okay. Someone, let us be specific. A is 0.5. Someone is telling us A is 0.5, good. And B is 2. Okay, good. Okay, this is very nice. A is 0.5, B is okay, good. Crispus, then I'm seeing Cosmos, Loda, Anthony. Okay, that is good. So hope everyone is getting that. But now afterwards, we shall go back and ask ourselves, what do we have for our A? That our A was this. So meaning I have log, then I remember the rule that says that when I have log AB is equal to M, this is the same as B equaling to A to power M. So what are you noticing now? That we have this as our, so meaning our B is the X equaling to A, which is 3, then our M is the 0.5. So 0.5 is the same as a half. So this is the same as 3 to power half. And we know very well that any number to power half, a half means a square root. So I can have this as root of 3. So you do the same when it comes to y, that I have log of 3y is equal to 2, meaning our y will equal to 2 to power 3, where y is equal to 2 to power 3 is 8. Okay, any questions? Any question? In case you have another question on logarithms, please can you raise up your hand and then you tell us. In case there is any problem. Yes, please.
Will it be y equals to 2 over 2, 2 to power 3 or 3 to power 2.
Or here?
Uh,
So here it is going to be, this is the rule we are using. This is the logarithm rule. So when you notice here, what is your A? So, oh, sorry, there is something I'm noticing. Okay, you are right. So here we shall have, this is the same as 3 to power
2.
Power 2, which gives us
9.
9. Okay, thank you. Thank you, that is very correct. Should we move on? Has everyone understood?
Yes,
We
teacher.
proceed.
Okay.
Yes, sir.
Okay. Okay.
No. Yes, teacher.
Okay. Can we do one more number on logarithms such that we are competent?
Yes, teacher.
So we are going to say so for x and y. So we have log 2 x minus 3y plus 2 equals to 0. And then I have log 2x plus 1 minus 1 equaling to 2 log 2y. Okay, let's first try that on our own. First try.
So,
Yes, please.
is that thing log of x plus 1 base 2?
Yes. The base is 2, then that one is x plus 1.
Okay.
So this is one thing. This x plus 1 is one thing. Let us first try. So these are some of section N numbers. Some of the section N numbers that can appear in algebra. However, they can as well appear in section B. They can appear in section B. So you need to be, and these are numbers that you must always pass. You must always pass. Any number concerning logarithms, you must always be able to pass it. Okay. Keep trying. In case you get stuck, we shall pick you. Okay, someone is stuck. Okay. Is there someone who wants to give us a hint? Anyone who wants to give us a hint? Someone can give us a hint. I'm also seeing Anthony saying he's stuck, Terry is stuck. Anyone who wants to give us a hint? Just a hint. I'm also stuck. Okay, someone is waiting. I'm also, oh, yes, Queen, Patricia, go on.
Good evening, everyone.
Good evening.
My idea on the question is that we apply the law which says for you to find the value of a number like that, we have two equations. We're going to generate the equations ourselves. From the first one where we're having log 2 of x minus 3y plus 2 is equal to 0, that one can become x minus 3y plus 2 is equal to 2 to power 0.
Like that?
Is equals to 2 to power. Yeah. Then from the second, because n number 2 is 0 becomes 1, so that one shall become x minus 3y plus 2 is equals to 1. Then the equation we get is x minus 3y is equals to negative 1.
Is everyone
Call that.
with
Yes, please.
I was inquiring from the members whether everyone is happy with this step.
Yeah.
Okay.
That's equation 1.
So this is our first equation. Okay.
Then from the second expression, we can get another equation by saying that because in logarithm 1, that means it was a log of the same base, and like it was log 2 of 2. That's why we're able to get that 1.
So meaning
Minus log 2. We carry the 2 up.
okay. Okay. I don't know. Is everyone happy with this step?
Yes, sir.
Yes.
Okay. Continue.
Then since the logs of the same bases, they are on the left-hand side, we shall divide. X plus 1 out of 2 is equals to. Then divide by log 2 on both sides.
So since logarithms have the same bases, you can equate the numbers. So we don't divide them, we just equate. So you don't divide logarithms, you just equate. So since they have the same base, we equate. Okay.
Okay, fine.
Is this? Okay. Can you end at that point and we leave everyone now to solve these two equations? So we have equation 1 and equation 2. Thank you so much. Now let everyone continue from that point. Okay, I'm saying Anthony is okay. Good. Okay, people have started getting the answers. Okay, so let everyone get the answers. Okay, when you get the answer, feel free to share with us what you are getting, such that the rest can compare with what everyone is getting. Okay. Okay. I think everyone is on track. So, okay. Okay. Oh, I'm seeing very many answers. Which one is which? I'm seeing some are getting x equals to 1, others x is equal to 17. Okay. Okay, so I'm seeing very many answers, and this one is telling me that we may need to do this number together. I'm seeing very many answers. Anyone who thinks his answer is okay? I'm seeing two different answers. Something might not be right, but all we have answers that are differing. X is 1. People are getting 1. And how are they getting the 1? That's what we need to know. So we are going to try it together and then find out what is the right. Because now if at all everyone is having something different, it means there is something. Okay, so let's do it together here. And we are going to start from where we have ended. So we had our first equation as x minus 3y is equal to -1. And then our second equation was x plus 1 out of 2 is equal to y squared. So the easiest thing I can first do in case I'm working it out, I'm going to first look at what I have and then I multiply. So what I can do here is something very easy. So let me hope we shall be able to do it. So this is what we had, but okay. Okay, so hope everyone is well conversant with what we have here. Okay, so I'm going to come back here and I said it's the same as x plus 1 equaling to 2y squared. So when you look at this, you are noticing that it's going to yield a quadratic equation. So when I come and I look at question 1, I have x minus 3y is equal to -1. Yes, Patrick? Patrick? Okay, so meaning we shall have -1 plus 3y. So I can come back where I have my x, I put -1 plus 3y. So I have -1 plus 3y. Yes.
Excuse me, sir.
Yes, Patrick.
Sir, I don't know how our fella got the equation to, but equation 1, I'm well versed with it.
Okay, just a minute. Like when you look at equation 2, you had log 2x plus 1, then minus 1 is equaling to 2. So this 2, I can make it come back here, and I remain with log 2y power 2. Is that fine? Is that step fine? Then what I can do, in case I want, I can have this -1 come over this side, and I have this one come this side. So I can say log 2 of x plus 1 minus log 2 y2 is equal to 1. Yes, Jesse? I'm providing an alternative in case you don't want to go here, whereby -1 is the same as log 2. So when I reach here, these logarithms have the same basis, meaning I can say, if at all it is a subtraction, then you divide. So I have x plus 1 over y squared is equal to 1. Then we know very well the rule for logarithms. This number can be a power this side. So I can say x plus 1 over y squared is equal to 2 to the power 1. And then you come back to the same thing. So you can either go this like this, or you can come directly like what she did. Okay. Hope it is fine. I'm just okay. So when I reach here, I know x is equal to negative 1 plus 3y. So I get it, I substitute, there is x plus 1 is equal to 2y squared. Negative 1 and the 1 is a 0. So I remain with 3y is equal to 2y squared. So I can have that 3y comes to the other side, and I have 2y squared minus 3y is equal to 0. So y is a common, and this is a quadratic equation, meaning I can factorize out y. I remain with 2y minus 3 is equal to 0, meaning that one of my values of y is 0, and the second value is 2y minus 3 is equal to 0. So this is 2y equaling to 3. When I divide by 2, divide by 2, I get my y as 3 out of 2, or 1.5. So I'm happy that most of us got those values. Good. Yes. Okay. Then I'm going to get back. Then after getting the values of y, I come back and I get the values of x. Where there is y, I put the x. So you are noticing that when my y is 0, I have my x as negative 1. Then you substitute. When your y is 3 out of 2, what values do you get? So that is how you work it out. I don't know that we have another question, but someone was asking how she came up with, how she got this. But remember that when you have log of 2, x minus 3y plus 2 equaling to 0, always this number can come over this side, and you have x minus 3y plus 2 is the same as 2 to the power 0. Always have this rule at the back of your mind, that when I have this is the same as n equal to a power bar. So this is the rule that she used to get the first equation. And any number to power 0 is a 1. Okay. Yes, it is also fine. So just say any, that approach is also okay. It is also okay. Okay, okay, okay. Then one aspect we have not yet looked at is proving in logarithms. You have noticed that most of the times, or some of the times, they can bring for you a number and then they ask you to prove it. So let's also ask ourselves, how do we prove it? Take an example. Can we also try and see whether we can work out this? So we are going to prove so we are proving, so you prove that log 3, 48 is equal to a plus b out of a minus b. Let's prove and see. We first work out and then we can do it together. Okay. Okay. When you prove it, you tell us that. Okay. Yes, Benjamin, first try. First try. In case you prove it and it comes out, please please use the chat and you let us know that it has come out well. Okay, Messianic has proved it. Okay, that is good. Okay. Okay, I'm seeing now these how many people. Okay, Musa, it is coming out. I've proved it. Very good. This is okay. This is okay. Yes, this who else? Okay, okay, okay. Should we leave it now? Since or there are some people who have not proved it.
No, sir, you do it.
Okay. Some people are still have not yet. Okay, can someone give us a? Okay, Julia Emma has not proved it. Yes, Emerson is stuck. Okay, some people are still stuck. Okay, which shows that at least we have to do it a bit. Okay, okay, but let's give just one more minute. Those who have finished, I'm going to give you another one. Okay, but we are going to first do this one, and then we go to the other one. Okay, anyone who has done it to take us through? Anyone who has done? Yes, Messiah, take us through.
Okay. So, good evening, everyone. So what I did, I don't know if I'm clear. So what I did, they gave us, they told us to prove that log 348 is equal to that. Am I clear?
I will go on.
Am I clear?
Yes.
Am I clear? Oh.
You're not.
Yeah.
Maybe you tell the other ones who have not muted to first mute.
Okay, let me first mute everyone. Okay. Irene, unmute and you speak.
Okay. So what I did, I used the right-hand side. So they told us A is equal to log 4m. So I substituted log 4m where A is in both cases. And the other side also where B is, I substituted log 12m.
Okay.
For A, I substitute log A, yeah. Then the other side also log 12b. Then out of the A was log 4m. Then for the B was log 12. Yeah. So since they told us to prove for log 48.3, so I changed all the logarithm part of the bases into log 3. That means I use log 4. I changed that log 4m to log 3. That will be m3 and divide by log to be 4.3, yeah, 3.4. Log 3.4 plus log, that was 3m, log 3m. Then you divide by log 312. Then all of it out of, the other side was log, yeah, log m3 out of log 4.3 minus that log 3m, then out of log, yeah, 12m. So since I never wanted my thing to be complex, I let log 3m to be equal to y. Then after there, log 3m, log 3m to be equal to y. Then I got the LCM of both sides. That means it would be, if it would be y for the case of the upper part of it.
Yes, it will be y.
To be y log 312. Log 312 plus y log 34. Then the LCM was log 34 log, yeah. So is it possible if you just go this side again, you say divide by, instead of putting all of it over?
Okay.
Divide by, yeah, that side. This will be y log 12, log 312 minus y log 34 out of log 3, yeah, log 3. So after that, I got the reciprocal, whereby this, the reciprocal, whereby all the denominators will cancel, and I factorize out y. Okay. out of log.
100 plus.
So from there, I factorized out the y. That means the y will cancel. And I worked out following the logarithm laws.
You get a job talking, man.
That will be log 3, 4 over log 3, 12 minus log. So from there, I follow the logarithm laws whereby you're going to multiply and you're going to get log 48. Log 3 out of 48, then it will be log 3, 3, which will be 1. So hence proved.
Okay, thank you, Irene. Anyone having a question?
Are we doing this now?
Yes.
They give you 12 marks and this.
Okay. Okay, Martha, hope you have understood. They told us to prove that log 48.3 is equal to that. So it is very fine. That's why she changed it to log base 3. Okay, is it clear now to everyone?
Yes. Yes, teacher.
Okay.
Excuse me, Mr. Kazu. I'm requesting to take a look at the last step.
Here?
Yes, sir, that very last one.
Okay, hope it is fine.
Yes, sir, it's fine. Thank you.
Okay. Okay.
Excuse me, sir.
Yes, please.
Hello.
Yes.
You just me scroll to the first page where she started from.
You want to copy?
Mr. More clarification,
No,
please.
I just want to say something.
Okay, okay, well, that is one. Another person, yes, Emerson?
Pastor, is it possible to start from the left?
Yes, it is very possible. It is very possible. Very possible. Have you tried from the left? It is very possible. Okay, because when they tell you to prove, you can come from either ends. It's not a must that you come from one end. You can come from either sides, but always look out for the easier way of getting to the answer. So always you look out for the easier way on getting to the answer. But in case you want, we could as well have it. Okay, maybe let me do the right hand. Okay, so in case I want to take the left hand side, I want to start from the other side. I know very well that I have my log of this is 4m is equal to a. And we know our rule says that if at all this is the same as having 4 equaling, sorry, this is the same as having m. Okay. So this is the same as having m equaling to 4 power a. So that is very, very true. So this is the same as having 4 to power a. So when I want, then in case I want, so this can be my first equation. But now I'm going to do something now. Since I'm proving, I can remove this A. So in order for me to remove this A, I have to get a root. Whenever I have something, let me say x squared is equal to 4. To remove this 2, it means that I'll multiply this side by half and I multiply this side by a half. So I can apply the same thing. So that means I can multiply, because this is a proof, that's why I wanted us to use the, so when I multiply here by 1 out of A, this side I can multiply by 1 out of A. So this A and this one cancels, so it remains with M1A is equal to 4. So I can call this one to be my first equation or my first expression. Then when I come to the next one, I have log 12M equals to B. So what will I have? This is the same as having M equaling to 12 power B. So I'm going to apply the same things here, that I'm multiplying this side by 1 out of B. I multiply this side by 1 out of B. So what will I have? I'll have M 1 out of B is equal to 12. And I can call this one to be my second equation. So when I look at 1 and 2, I am noticing that when I multiply the two equations, I'm going to get 48 somewhere. So I'm going to multiply 1 and 2. So when I multiply, I have M1 out of A times M1 out of B equaling 4 times 12. Are we together on that step?
Yes, teacher.
Okay. So when you look at these numbers have the same basis, meaning I can add the powers. Meaning I can have 1 out of A plus 1 out of B is equal to 4 times 12 is equal to 48. So meaning I'll have M. Here my same is AB. So I'll have B plus A out of AB equaling to 48. So when I look at this, since they want me to prove that log of 348 is equal to something, it means that now I can introduce the same logarithms on both ends. So I can introduce log of 3 here and log of 3 the other side. So I can say log of base 3m, then b plus a out of ab is equal to, this side I have log of 348. So I've introduced the same logarithms on both ends. So what am I going to have? I can have now this power dropped. So when I drop this power here, I'll have b plus a out of ab log 3m equaling to log of 348. But what do I know very well? I know very well, you can ask yourself, do you have log of 3m? Do we have it? No, I don't have it. But I know very well that my m, when you look, you remember that we know that our m to power the m you had m equaling to 4 to power a. So we have this somewhere here. It was one of our expressions. Here we said m is equal to 4 power a. So after me getting m is equal to 4 power a, I'm going to bring it here where I have m and I substitute this. I have b plus a out of ab. I'll have my log of 3, 4 power a equaling to log of 348. So the next step I'm going to do is that I'm going to drop. So I can have this a dropped over here. So I have b plus a out of ab, then times a log of 34 equaling to log 348. So this a and the a we have down here are going to reduce. So now it means I'll have b plus a out of ab. Sorry, a has reduced. So we shall have b. Then I have log of 34 is equal to log of 348. So that is now. But now you still have, so here it is when m is equal to 4a. what about when m is equal to 12b? What does it mean? It means that if at all m is equal to 4a and m is equal to 12b, the values of m are the same, meaning that now I can have 4a is equal to 12b. So what does it mean? If at all what am I looking for? I'm looking at how am I going to eliminate this expression? How am I going to eliminate log of 3, 4? But I come back here. When I introduce log of 3, 4a, I introduce log of 3 on both sides. This will be 12b. So what are you going to notice? You're going to notice that this a can drop. So I have a log of 3, 4 equaling to, I'll have this side be log of 3, 12. But what am I looking out for? I'm noticing that this is the same as b. When you notice 12 is the same as 3 times what? Times 4. So I can have this as log of 3, 3 plus log of 3, 4. That one is that expression. It comes from there. So what will I have? I'll have here now my b. This one is the 1 into 1 plus log 3, 4. So I'll end up with this side I'll have b plus b log of 3, 4. And this side I'll have my a log of 3, 4. So when I make log 3 for the subject, I'm going to have this one come over this side. So I can have this log 3 come this side, and I have log of 3, 4. Let me say this is my a minus b log of 3, 4 equaling to b. And when you look here, log of 3, 4 is common. So I can say log of 3, 4. When I factor out, I have a minus b equaling to b. Meaning that your expression for log 3, 4 is the same as b out of a minus b. So what am I going to do? I'm going to come back in this expression I had initially from here, where there is log 3, 4, and then I'll substitute with b out of a minus 4. So I'll have b plus a out of b, then times b out of a minus b is equal to log of 348. So this b and the b will cancel, so I remain with b plus a out of a minus b equaling to log 348. And therefore, you have proved it. So I don't know whether you have understood that route. So always when you are proving out, always there is an easier way. There's always an easier route. So always first look out for the easier route before you go in for the other side. So always you first look at the left and the right hand side, which one is easier. So always there is that easier route that you can use to get to the answer when it is just proving. So those who wanted to use that approach, that's how you could go in case you had gone from the left towards the right. Is that fine? Hope that is okay. And but there isn't okay. Okay, the easiest route you could use could be what Irene gave us, but all routes could get you to the right answer. So now allow me to first drop this link such that you register yourselves. So just click and fill in your details, and then I want us to first discuss which topics do you want to cover. That is the first thing, because I want us tomorrow that will come up when we have shared. So as you are registering, please raise up your hand and you tell us that this topic and this topic. Yes, Irene. Irene?
I'm sorry, I left my hand up. But for the case of math, I would like, if it's okay, we discuss vectors, vectors math, vector math.
Okay.
Or for pure math, paper one.
Okay, vectors, good. Okay, yes, another person? Yes, Daphne?
Yes, vectors. Iwe, bagenze. Anube.
Okay, vectors. Okay, vectors. Okay, yes, Winnie? Okay. Okay. Let's first see. I want to hear those saying vectors you can type, others you can type. Yes, Daphne, let us start from Daphne. What are you like?
Trigonometry.
Someone is saying trigonometry.
Vectors.
So we are going to go with the majority. Winnie. Yes. I'm not saying very many answers in the chat, but please, I'm saying, okay. I'm not seeing people of vectors, vectors, the ease, further integration, parabolas, conic section, maximum, minima, vectors. Okay. So can we agree that we do this? Another one is saying trigonometry. Okay, can we agree? So I'm going to take the majority. So I'm going to see whether we go in for vectors or the ease. But if at all we are to go in for the ease, it will need that people have covered their differentiation and comparison. But let us see that, okay, someone is suggesting, okay, they have already suggested. So we shall either have vectors or further. I think vectors is the one that has come in mostly. So we shall have vectors and then we shall see what we shall have. Good enough. Vectors doesn't require you to have some knowledge. It requires just some simple knowledge. So we shall also have it. But some of these topics, we shall also meet them during the seminar. Then those doing biology and chemistry, please go on and pick a question that you are going to discuss over, I think is it on Thursday and Friday. Kindly pick a question that you would love to discuss, write on a piece of paper, and then share such that we can prepare for that session. So we shall be meeting those who are going to be discussing for your friends. The teachers are going to be available, but please, we need to prepare such that they all pass. It is hard to help someone who doesn't have anything. But if at all we have something, it will be easier for the teachers to all pass. Yes, Nella. Nella? Okay. I think we are going to end here. Can we ask someone to lead us in a closing prayer? But all these topics, don't worry, they are going to be provided. I'll send in those WhatsApp groups all the topics. All the topics, I will send them such that in case you have not covered any of those topics, then you can go through. Okay, yes, can we have someone to lead us in a prayer? Nella, I don't know if the answer brain is on. Can we have someone lead us in a prayer?
Let us pray. Heavenly Father, above the seven heavens and the earth, we thank you for this mighty time that you've granted unto us. We thank you for this lesson that we've had. We thank you for our mighty teachers that you've enabled us to meet with after this time at school. That we ask you to grant them knowledge, increase them in understanding, and grant them their wishes, their strength, combinations. Father, we ask you to grant us knowledge to understand what we've learned, remember us so that we for our friends next time. In the mighty name we pray. Amen.
Thank you so much and have a good evening. Thank you. Okay, those who want the WhatsApp link, let me share it here. Thank you. Have a good evening. It is there. Those who want to join the WhatsApp group. Okay, have a nice evening, everyone.